This recording is for 4.4, graphing rational functions. So 4.3, in fact, is a preparation for us to know to start graphing rational functions. So let's take a look at says the steps. I don't like to just right away talk about the steps, which seems to be very mechanical. However, after you try by yourself, after a number of try and error, you would know that yes, these should be the steps for how to graph it. All right, now let's take a look. Now we do know rational functions, that is fx, that has a polynomial function gs as a numerator, and hx, another polynomial functions, as a denominator, and this is a rational function. In this case, gx does not equal to 0, hx does not equal to 0, otherwise there's even no function here. So the step one is to find the vertical asymptote. Okay, the vertical asymptote. Now, because as soon as the denominator is 0, then you got these vertical asymptote, such as x equals to a or x equals to b, or either one or a double, or different vertical asymptote. Now, second step is then we're going to find the horizontal asymptote. Okay, now when we find horizontal asymptote, here says divide by the highest power. So what that means, you can also remember that if gx, the highest power is to m, and then this is a, let's just say it's a a1 or am, and then your hx, you have the coefficient, let's say an, and then your highest power is n. So now if m is smaller than n, then you will have y equals to 0. That is your horizontal asymptote. That's the first one. But if you use divided by the highest power, you will get this, right? So last video we proved how that happened. Now next one is if m and n, they're the same power, and then your asymptote will be the leading coefficient, which is am over an. Now the third possibility is that if your power for the top is higher than the bottom, then there is no horizontal asymptote. All right, so let's figure out right from the beginning, we'll figure out these two, and then on your graph, draw these asymptotes. And then the third one is find the x and y intercepts, because this is very, very important, these points, and also the holes. This is also very important. So we got x-intercepts, y-intercept, and holes. So we're going to figure that. And then we're going to make a table of values. Now, making a table of values is one thing, but the most important thing, as we also talked about in last video, is how to choose values. This is very important. So in terms of that, so first of all, find the y-intercept. That is fine, right? So this way I'll know this is over here. Now choose the values close to vertical asymptotes, and one large positive x value and one large negative x value for x, and then plug the points and then connect the points and smooth the curve. Easier said than done. So let's just take a look at the examples and see how we can graph this. All right. So now, first of all, I want to point out to you that there are about how many examples in the textbook? I'm just looking at the my textbook here. So we have 4 examples here. All right. So I have example 1, example 2, example 3, and example. There's also 3 has 2 graphs to graph, and we have example 4. Okay, so they're all very typical rational functions. So then let's take a look, and I won't be able to go through them all because the video will be too long, and nobody's going to sit around for listening to me talk for that long. So now then take a look at the first one. So this is a very typical function for rational function. All right, so now the first step, of course, the first step is to figure out the vertical asymptote. Okay, so the vertical asymptote is x cannot be equal to 1. Therefore, the vertical asymptote is x equals to 1. All right, now for your work, this is the steps that I would like everybody to write it out. So then the first step is vertical asymptote, and the second one is horizontal asymptote. Now in this case, it is, this is x to the power of 0, right? Or sorry, I probably should write it here, x to the power of 0. So therefore the 0 is smaller than 1. Therefore your x-axis is the horizontal asymptote. So now figure out this first step. Now the second step, we're going to also figure out the x-intercept and y-intercept. In your here, it got the table value going first, but not necessarily I like to do that. I like to have the second step. Just follow the steps above. The second one is our y-intercept. So y-intercept, intercept. So that means when x equal to 0. So x equal to 0, and so when x equals to 0, y equals to negative 2. So this is a negative 2, and that is y-intercept. Another way to write is y-intercept is y equals to negative 2. Okay, so then let's see what is x-intercept. So x-intercept. X-intercept is when y equals to 0. So when y equals to 0, so you take a look at it here. It is equals to 0. This equals to 0. Then it's undefined. So that means there's no x-intercept. So this is not applicable. All right. Now the third one is we're going to see the table of values. Okay, so table of values, which said here above, is that we wanted to choose whether or not the value is very close to the vertical asymptotes. Oh, by the way, here, do we have holes? We don't have holes, right? So holes, and there's no holes. Okay, all right, so now let's take a look at table values. Table values, because where vertical asymptote is x equals to 1. So in this case, we want to choose the value that is either called 1 positive or 1 negative. What does that mean? It means 1 is the values that's larger than 1. So if you have a number line here, so if you have this is 0 and this is 1, so you want to choose a value that very close to the 1, but from the positive side means that larger than 1. So for example, 1.1 is larger, 1.01 is even better value. All right, but here we go, because it's 1.01 is even closer to 1 than 1.1. But this is probably already good enough. So then this 1.1 value, plug it into here, because 1.1 subtract 1 is 0.1. 0.1, 2 divided by 0.1, it gives you a 20, right? So that's your y value. And then from over here, approaching to 1, from the other side, then that means it is 0.9. So we got a 0.9 here, or we could also do 0.99, even closer to 1. But this is already good enough. So then this means that is negative 20, because 0.9 subtract 1 becomes a negative number, and then it's negative 20. So in this case, you see, this is our asymptote. So here we always, right from the beginning, draw this vertical asymptote and draw the horizontal asymptote. And then we started plugging values. So we have y-intercept, which is right here. We don't have any x-intercept, fine. And we don't have any holes, fine. And then after that, we're going to come up with a table of values. So one is 1.1, so it's 1.1. It's way at 20, somewhere here, right? So you can see the trend, because if you get it to 1.01, that's even higher. So then negative, so then your 0.9 is down here, is a negative 20. So you can see this is going down, this trend here. So on either side of your vertical asymptote, you can see the trend. Your y value is either going to the positive infinity or going to the negative infinity. All right? Now, you also wanted to find a very large x value. So very large x value, so we try a 100. Okay, so if this is 100, 100 minus 1 is almost just like, you can just treat it as 100, because the larger the value x is, this minus 1, it's become very insignificant. So then that becomes 2 divided by 100 becomes 0.02. 0.02, that means so close to 0. And then your next one, it is the same thing, that negative 100. Negative 100, it becomes a negative number. So the negative number is, y value is a negative number, but approaching to 0 from the negative region. Now, let's say we also wanted to find a couple of values in this region here, right? In this region and also in this region, to just give you some kind of, this is shooting up top, this is going down to the 0, this is moving up close to 0, 0, 0, and this is shooting downwards. But how about give a couple of values here? So then we can choose another value. So when x equals to negative 1, close to, if you have a 1, I give a negative 1. So if it's a 1, I give a negative 1. And negative 1 is over here. So this point is important to kind of give you, because now you have this point and you have this y-intercept, you can know this curve is like this. Now, you can also have a x equals to 0, because x equals to 0, then that is negative 2. So x equals to 0, oh, this is right here. This is our intercept. So then you can also have an x equals to 2. X equals to 2, and then it's a positive 2. So then that is this value here. And then you can have x equals to 3, and then you have another value here. And then you have these 2 points to give you a curve for this curve. All right, so this is how we are graphing a rational function. And I will do another video to give you more examples in order to not have one video to be very long. Thank you for watching.